So let's talk a little bit more about measurements. We mentioned that measurements have two parts, a number and a unit. So here's some examples. 20 grams, 6.63 times 10 to the minus 34 joule seconds. Now, joule seconds is a weird unit, but that's the unit. This times 10 to the negative 34, is that a really, really big number or a really, really small number?
Small.
It's a really small number. That would be 0.3300663. Teeny tiny number. We deal with those things in science. Really important, though, to have the unit in there. There's two basic systems of units. The English system, which is what we generally use here in the United States, and the metric system, which most of the rest of the world uses. I don't know, that's some commentary on Americans, I think. There's also the international system, or SI system. The SI system is very closely related to the metric system. They are not exactly the same, but the differences are so subtle that in this class we're going to treat them as though they were exactly the same. The SI system has some different base units than the metric system does. The difference just really doesn't matter at all. So I'm going to use metric and SI system interchangeably, even though they're technically slightly different. The units are all the same, just how they talk about them is different. So in the SI system, the unit for mass is the kilogram. That's the fundamental unit. So kilogram is a very lovely unit. We don't use it a lot in chemistry because it's a big amount of mass. A kilogram is 2.2 pounds. When we do experiments in chemistry lab, we never use 2.2 pounds of anything. Except well, when we make ice cream, we probably use that much ice. Way more than that much ice, but that's an exception. We are going to make ice cream at the end of the semester. The unit of length is the meter, time is the second, temperature is the Kelvin. Electric current, we're not going to deal with that in chemistry. Amount of substance is the mole. We'll learn about that later. These units all have abbreviations. The abbreviations are very specific. You know, sometimes when you're talking, you use the wrong word, but the person you're talking to knows what you meant, right? And so you just go on. And then you sometimes run into a person with poor social skills that corrects every little thing you say. One of my kids is doing that. I'm trying to learn not to do that, but one of my kids does that, and so we're trying to teach him not to do that. But he'll just, you know, everything has to be exactly correct. And that's frustrating to a lot of people. And in just general life, it doesn't matter that much. But when we come to writing units and numbers, there is precision, and there's a particular way that we do it, and so we do have to get it exactly right. The element symbols that hopefully you've started to memorize. You know, copper is Cu and calcium is Ca. And then there's cobalt is Co. Cobalt is Co, copper is Cu, even though both of those words start with Co. So what's the big deal if you call copper Co? Well, it is a big deal because everybody reading that is going to think about cobalt and not copper. With these units, there's a limited number of letters that we have for abbreviations here. And so we make use of the lowercase letters and the uppercase letters. And so a capital M doesn't mean the same thing as a lowercase m. And so you can't just make up your own abbreviations for these things. We all have to use the same abbreviations, otherwise we won't understand each other. So I know that's frustrating for some of you. I'm sorry, there's just no way around it. In the SI or metric system, prefixes are used to change the size of the unit. Let's think about the English system, because that's what most of us are more familiar with. We measure length in inches and feet and yards and miles, right? So would you measure the length of this remote control in miles? No, because the number would be really, really tiny. But also you wouldn't measure the distance between Reedley and Fresno in inches, right? It's kind of ridiculous. We want to use a unit that is similar in size to what we're measuring. You know, if we measured the length of this room, we might use feet or yards, but we certainly wouldn't use inches or miles. So we want a unit that's going to be in the ballpark the same size. And that gives us nicer numbers. Instead of, 4,723,000 inches, we can say it's 30 miles. So in the metric system, instead of having different units for these different sizes, we just have a prefix that scales them up or scales them down, and it's all based on powers of 10. So if we, a meter is about the same length as a yard. So if we're going to measure the distance between Reedley and Fresno, a meter is too small. We wouldn't measure that in yards. We need a larger unit. Well, let's throw a prefix in front of meter. We would probably choose kilo. Kilo means 1,000. A kilometer or kilometer is 1,000 meters. And that ends up being on the ballpark of a mile. It's like 1.6 miles, I think. A ballpark. So that's a much nicer unit. If we're going to measure the diameter of a hair, the hair on your head, not a rabbit, pull a hair off your head, you're not going to want to use meters because a meter's long. It's too big to measure the hair. You want a small unit. So we're going to choose a prefix probably like micro. Micro means 1/millionth of a meter. So it's a meter. It's 1/millionth of a meter, a little tiny fraction of a meter. That gives us a unit that's really tiny, that's appropriate for measuring small things. So there are prefixes for every power of 10. We don't use all of them, though. These are the more common ones, and the ones we use frequently in chemistry are kilo, centi, milli, and micro. I'm pretty sure those are the ones I put on that list for you to memorize. You would measure the wavelength of light using nanometers. And there's even picometers, which are 10 to the minus 12 meters. And there are things larger than mega, too. So this is just the more common ones. We don't use, deci is a great unit, but we don't use it very much in chemistry. But these are the symbols. There's mega. Mega starts with an M. Mega is big. Mega is a million. So, we sometimes use that term in everyday life. Well, he's making mega bucks. Well, literally a mega buck would be $1 million. You could use these prefixes in front of any unit. Mega anything. You could say mega feet would be 1,000,000 feet. People look at you like you're weird, but we would understand what you meant. Yes? Right. Exactly. We do use these metric prefixes in measuring memory in computers. So there's kilobytes and megabytes and gigabytes and terabytes. I have a 1 terabyte hard drive. When I first started using computers, we won't even go there. Anyway, that is mind-boggling. Okay, so those prefixes are kind of trickling into our everyday life. But mega is, I think we've heard that one enough. We understand that's big. That's a lot of something. That's a capital M. Milli also starts with M. Milli is a lowercase m. Milli makes it smaller. A millimeter is 1/1000th of a meter. A milligram is 1/1000th of a gram. So the one that makes it bigger is a big M, and the one that makes it smaller is a small m. And then there's micro, and we ran out of English M's. So then we go to the Greek alphabet, and this is the Greek letter mu, which is the lowercase Greek mu. And it's like a U with a funny tail on the front. and we will be using that. Okay, so that's, so here, capitalization matters. And the other thing that's you got to be a little bit careful about is how big are you writing your letters. Okay, so if I write an M like that, is that a capital M or a lowercase m? There's no reference, right? If I do that, okay, so that's 5 millimeters. That would be 10 megameters. The abbreviation for meter is a lowercase m. And so we can use that as a reference size. If the prefix letter is the same size as meter, that's a lowercase. If it's bigger, it's a capital. And I know that some of you are, well, let's say, handwriting challenged. I have several children who their handwriting is just atrocious. But most of you, if you really want to, you can form letters more neatly. One of my sons, his regular handwriting is pretty hard to read. But when they did the cursive exercises in, what was that, 3rd or 4th grade, it was beautiful. It took him forever, but it looked exactly like the example. It's like, okay, Tommy, the game's up. I know you can do this. But most of the time, that's way too slow. And so he writes sloppier and faster. So I guess what I'm telling you is there are times when it's really important that you form your letters in the correct size and neatly so that we can read them. So when you're writing your answers, please write them so that I can understand what you're meaning. So this part of this table is what I've asked you to memorize. You need to know the prefixes. It's not all of these, but the ones on that list, what their symbols are, and what their meanings are. These are the meanings expressed in decimal form. These are the meanings expressed in powers of 10. These are the ones I'm going to use in class, the powers of 10. Because they're, especially when you get to the really big and really small ones, it's so much easier. The micro, I don't want to have to count out how many zeros I'm writing. It's just 10 to the minus 6. So any questions about metric prefixes?